Welcome to Fluid Coding and AI. A clean install can pass dependency checks and unit tests, then fail when an agent framework loads its real provider. Let's compare 3 defenses. The case is specific. Pydantic AI version 2.32.2, using its Anthropic Extra, was installed in a fresh environment after Anthropic released its Python SDK version 1.0. The resolver accepted the combination. PipCheck reported no broken requirements. Yet constructing the production Anthropic agent crashed before a model response and before any request was sent to Anthropic. By the end, you'll know which defense prevents that surprise, which one detects it, and which one actually repairs it. Here is the clean reproduction. The environment selected Pydantic AI 2.32.2, Anthropic 1.0, and httpx 2. Legacy httpx was not installed. Installation exited successfully, and PipCheck said, no broken requirements found. Then the application constructed an agent with an Anthropic model string. Provider loading immediately raised, no module named httpx. This was not an API outage or a rejected prompt. The code had not crossed the network. The failure happened while the framework was assembling its production provider. Nothing supernatural happened. The resolver checked declared version ranges, not Python object compatibility. Pydantic AI allowed Anthropic versions from 0.108 upward, with no upper cap, so 1.0 was legal metadata. PipCheck verified that the installed packages satisfied those declarations, and unit tests using Pydantic's test model could still validate tools, schemas, and agent logic without importing the production Anthropic adapter. Every green check was honest. Each one answered a smaller question than the application needed answered. A provider construction test would have asked that larger question, but this suite had. Here is where my expectation changed. The obvious fix was to install the missing legacy httpx package. That removed the import error, but the application still failed. This time, Anthropic gave the real diagnosis. It expected an httpx2 async client, but Pydantic AI supplied an httpx async client. The error got better. The app did not. That second failure reveals the actual bug. 2 libraries disagreed about the transport type crossing their shared boundary. Anthropic's version 1 release intentionally replaced legacy httpx with httpx2, raised the minimum Python version from 3.9 to 3.10, and removed other deprecated behavior. A major version is exactly where semantic versioning allows that kind of break. The compatibility window came from the older Pydantic AI release, accepting Anthropic 1.0 without supporting its new transport contract. Pydantic fixed that in version 2.33 only hours later and documented the temporary pin for applications that could not upgrade. Defense 1 is a fully locked application. Resolve every direct and transitive dependency to exact versions, commit the lock, and deploy from that reviewed graph. For the old line, Pydantic AI 2.32.2 with Anthropic 0.125 and legacy httpx 0.28.1 constructed successfully in the clean check. A full lock would have stopped a routine rebuild from silently selecting Anthropic 1.0. It also gives you an exact inventory for rollback. But a lockfile is a time machine, not a test. It preserves yesterday's graph. It does not prove tomorrow's upgrade works. Defense 2 keeps a sensible compatibility range, then challenges it in CI. Create a clean environment, deliberately resolve the newest allowed packages, construct the real provider with the application's actual client configuration, and cross the boundary with a bounded smoke test. A mocked httpx2 transport can catch request and response type problems without a secret. A trusted job can make one tiny request and verify a non-empty response plus provider and model metadata. That single call is not a benchmark, and it cannot promise uptime or model quality. It proves one narrower, valuable thing. This candidate dependency graph can complete the provider path. The important detail is that this cannot be the same locked lane you deploy. The deploy lane should reproduce the reviewed graph and refuse silent lock changes. A separate canary dependency lane should re-resolve the newest allowed graph. If that candidate passes provider construction and the bounded smoke, it can become a reviewed lock update. If it fails, production keeps using the known graph while the team investigates. This separates stability from discovery. Otherwise, a smoke test against the old lock merely confirms that the old lock still works, which is comforting but not especially adventurous. Defense 3 repairs the known contract. Pydantic AI 2.33 or newer supports Anthropic 1.0 and uses httpx 2 at the provider boundary. For this comparison, version 2.34 is a valid fixed migration target. Version 2.35 was already the latest release when the research was verified, and it carries the fix forward. With the default client, the migration may be small. With a custom client, replace the injected httpx async client with an httpx2 async client, and make its timeout, limits, transport, authentication, hooks, and request types come from the custom client is where a one-line dependency update can become real migration work. Proxies, enterprise certificates, mock transports, event hooks, raw response handling, and application performance monitoring may all touch the old HTTP family. Python 3.9 is also below Anthropic version 1's new floor. And any injected async client still needs a proper shutdown lifecycle. The useful rule is simple: when your application passes an object across an SDK boundary, that object's concrete type becomes part of your dependency surface. You own the seam even when neither library does. So which defense wins? Locking is strongest against surprise install drift and lowest risk for today's deployment, but it does not explore new combinations. A newest resolution smoke is the best early warning for the provider seam, but live calls need secrets, cost a little money, and can fail for operational reasons. Migration restores the supported path for this known break, but it does not prevent the next transitive shift. These are not competing philosophies. They cover different time horizons. Preserve the known good state, test the candidate state, then adopt the repaired state deliberately. The production pattern is layered. Declare a justified support range. In a separate canary lane, resolve the newest allowed dependencies and test the real provider configuration. Use a bounded live smoke where secrets are safe, with separate checks for tools or structured output if those modes matter. Review the resulting dependency change, update the full lock, and deploy from that lock. Keep fast model substitutes for unit tests. Just stop asking them to prove a boundary they intentionally replace. The larger lesson travels well beyond this incident. Test the seam you do not own. If this saved you from trusting the wrong green check, like the video and subscribe to Fluid Coding and AI for more practical breakdowns of the boundaries where frameworks, providers, and production systems meet.